The last section of Unit 3 is transformations on functions, which a lot of this is review material, things you've seen in Algebra 2. So in class we started with just some examinations of different kinds of functions and how they behaved in the coordinate plane when we did different kinds of changes to them. So we'll just play around with a function. We'll start with an absolute value function, maybe absolute value of x, and we know that's a v-shaped graph. If I do some sort of change on that function, for example, let's make the function f1 of, in parentheses, x plus 3, we want to know what happens when we add 3 to the absolute value function. So enter. So we can see that adding 3 shifts the graph to the left 3 units. It's kind of counterintuitive. We want to think of plus 3 as being a move to the right. But technically, the general form of the equation is x minus some number. So if we subtract a negative, we end up with a plus 3. So we really think of it as a negative move, which moves us to the left. If we had a minus 3, it would move us to the right 3 units. Okay, back to the f2 function. Let's take out the plus 3 and move the plus 3 outside the parentheses. So now instead of adding 3 to x itself, we're going to be adding 3 to f of x, which is another name for y. Press enter and we can see that the graph has moved up 3. So we literally are adding 3 to each of the y values of the original function. So on the original function we had a 0, 0 that is now moved to 0, 3. The point 1, 1 moved up to 1, 4. So we've added 3 to each y value. If we change that plus 3 to a minus 3, the only change is that it moves down instead of up. In general, things that are done to the x move things in the x direction, left to right. Things that are done to the f of x or the y do things in the y direction, up and down. So when we add or subtract in parentheses, we're doing left to right motion. When we add or subtract outside of parentheses or any other grouping symbols, we're doing vertical motion, up and down. Okay, so we need to be able to shift, translate, left, right, up, and down. Next piece of information is if we want to reflect something. Well, actually, let's stretch first. Let's multiply f of x by 3. So we'll do 3 times f of x, which is 3 times the absolute value of x. And take a look at that one. And we can see that for each point that was on the original graph, like say 1, 1, that is moved to 1, 3 on the new graph because we've literally multiplied each f of x or each y value by 3. So a point that originally was at negative 2, 2 now has moved to negative 2, 6. So we multiply by whatever that factor is in front of f of x. If that factor is smaller than 1, say 1/2, 1/3, 1/5, then instead of stretching out and looking taller and skinnier, it's going to spread out and look shorter and wider because our vertical change is going to be smaller than 1. Okay, so if we're inside parentheses instead of outside the parentheses, so we'll take away that times 3 and put the 3 inside. Multiplying x by 3, intuitively we would think that would triple the x coordinates. So an x coordinate that had been, say, 1, like the point 1, 1, we would expect it to move to 3, 1, and the graph would spread out, which is actually not what happens. When we take a look at that graph, it turns out to look exactly like the one before, because the things that we do to the x's work differently than the things we do to the y's. Instead of multiplying x by 3 in the graph, what we've actually done is multiply x by the reciprocal of 3, which is 1/3. For example, the point 1, 1 that was here has moved to 1/3, 1, which is here. A point at 2, 2 has moved to 2/3, 2. So we literally take 1/3 of each of the x's. So a 3 inside the parentheses does the same thing as a 3 outside, because what's going on the inside is a reciprocal multiplication factor. So it's a little bit odd. Let's go back to the original and change that times 3. We'll just take it back out. Okay, so we need to be able to stretch and shrink. So we stretch and shrink when we multiply. We multiply inside the parentheses. It stretches or shrinks in the x direction horizontally. And multiplying outside of parentheses stretches or shrinks in the y direction vertically. If we stick a negative in front of a function, so I take the opposite of f of x, so that's opposite y's, then we reflect that graph over the x-axis. So a point at 1, 1 will move to 1, the opposite of 1. A point at -2, 2 would move to -2 opposite of 2. So we're literally taking the opposite of all of the y values. Well, if that's the case, then if we take that negative off and we stick the negative in front of the x, it means we should be taking the opposite of the x's. If we take the opposite of the x's, 1, 1 should move to opposite of 1, 1. And 2, 2 should move to opposite of 2, 2. The tricky thing about that is, when I graph that, I can't tell it's a different function. It actually has been reflected in the y-axis. But when you reflect the graph of absolute value in the y-axis, you really can't tell because it was already symmetric over the y-axis. If I do just one quick little change to the original function, maybe make it absolute value of x plus 5, then I can tell that the original function, which is has a vertex over here at -5, 0, when it gets reflected in the y-axis, it comes over here to +5, 0. So we get the opposite x values and the same y values. For the test, you need to be able to do reflections, translations, and dilations, stretches and shrinks on graphs of functions. You'll need to be able to graph those. You'll also need to be able to just make a list of changes if you examine a function or examine the equation of a function. So, if you take a look at your transformations notes packet, the first page you see is just a summary of the transformations. So we start with this general form at the top, and you'll notice that f of x is in there. F is here, x is here. But a lot of new things are around, which means the a, the b, the c, and the d, those represent transformations that we can do on the function. Multiplying by a will do something in the vertical direction. Multiplying x by b will do something in the horizontal direction. Subtracting d from x will do something in the horizontal direction, and adding c outside the parentheses will do a vertical change. If we examine all those changes in written form, it's a little bit overwhelming, so we'll speedy through it real quickly. If a is negative, that means we're going to reflect it in the x-axis. So if we have a negative outside the parentheses, we're going to do a reflection in the x-axis. If I ignore the negative and look at just the number a, and I can say that's the absolute value of a, that controls the vertical dilation, stretch or shrink, and if that number is bigger than 1, we're going to stretch it by a factor of a, and if it's between 0 and 1, like a half or a third, then it shrinks, it gets shorter. C, which is what we're adding outside the parentheses right there, controls the vertical translation or shift, and if you add a negative, it's going to shift down, which is the same as subtraction, and if you add a positive, c greater than 0, then it's going to move up c units. This is just a summary of all the vertical things that you can do. And then down here you have a summary of the horizontal. You'll notice in the horizontal realm there are some things that are different. B is negative, then we're going to reflect in the other direction. It's in the x direction, which is over the y-axis. B controls a horizontal dilation. That's what we're multiplying the x by. But in this case, if b is bigger than 1, like 2, 5, 7, it's actually going to shrink because it shrinks by a factor of its reciprocal. So if there's a 3 in front of the x, we're going to make it 1/3 as wide. On the other hand, if we have a b between 0 and 1, say my b is 1/5, then it's going to stretch by a factor of 1 over 1/5, which is 5. So in the horizontal direction, big numbers make shrinks and little numbers make stretches. It's counterintuitive, it's backwards from the way we think it should work, but it does work. Last but not least, the D is a little bit tricky. If you notice in the equation at the top, we have an x minus d. And if we put in a negative number for d, like x minus -5, that changes to x plus 5, which is a move to the left. So if d itself is negative, then we would actually be seeing an x plus something. So if we look at that summary down here, if d is less than 0 or negative, then we're going to translate to the left because it's going to end up being a plus in the equation. And if d is bigger than 0, we'll get a minus in the equation, and it's going to translate to the right. Last but not least, if you have multiple operations going on the same problem, order of operations is the boss. So when you have to both dilate and reflect and translate, you have to do it in order. Multiplication and division is always done first, which means we want to do our dilations and reflections before we do any shifting up, right, left, or down. If we do things in alphabetical order, it actually will take care of all the operation orders. So notice the A and B are dilation factors. Those are things we multiply by. Those should get done first. And then the C and D are added, subtracted. Those should be done last. Okay, on to the notes on the next page. We'll fit 3 examples on this video, and then we'll have to switch to the next video to finish it up. So if you'll look at the second slide, just 3 quick examples on this one, or actually 2 quick examples on this one. We're going to take a look at some transformations on a graph of f of x that make a new graph g of x. So I've taken f of x and I've done some addition, subtraction, and multiplication on that. And I need to just make a list of what those transformations are. Everything inside the parentheses that follows the f is the input, which means those are all things that happen in the x direction. So I'm going to always start with what's inside the parentheses because that's going to keep me from getting my vertical and horizontal mixed up. The plus 5 that follows the x is going to move the graph to the left 5. The 3 in front of the x is going to multiply all the x's by a factor of 1/3 on the graph. So it's actually going to do a horizontal shrink by a factor of 1/3. So it's going to shrink it in 1/3 as wide. Things outside the parentheses are being done to f of x or the y. So the minus 7 is going to move the graph down 7. And the 2 that we're multiplying by is going to do a vertical stretch by a factor of 2. Alright, we're going to fit one more example on this video segment, so let's do this next one. The next one is ready to examine with one exception. Inside the parentheses where the input is, that always needs to be in factored form. So we're going to pull out a 2 and write the x minus 2 as a separate factor. So that should actually be a 2. And I'm having trouble just writing things down. That should be a 1. Okay, examine what's on the inside first. So the minus 2 moves the graph to the right 2. The multiply by 2 in front of the x does a horizontal shrink by a factor of 1/2. Outside the parentheses does vertical stuff, so the plus 1 does a vertical shift. We'll just say it goes up 1. In front of f, we have an opposite that's going to give us opposite y's, which means it's going to reflect it in the x-axis. So reflect in the x-axis. We'll finish this one up. And video segment part B we'll pick up at the next slide.